Bogomolov. He's from HSE, from Moscow, I guess, also from Korat, right? From Institute. So he'll be talking about on the basis of a Lagrangian fibration for a compact hyperkahler.
Thank you for the invitation. This is my first time at Bogomolov. The goal of my talk is a very particular type of Lagrangian fibration. Since the mini course, I want to say what is it in general. So in general, it acts as smooth manifold. General. Real case. W. Non-degenerate. Then Lagrangian fibration is a map. Em, so half dimension, is a toric fiber, E, so generic fiber. And any and tangent bonds to the fibers, tangent bond to the fibers, or isotropic, maximum isotropic to with respect to the. Okay, so the things we have a fibration. That the standard locally it's a real big picture. Local, so we have a torus and its tangent bundle is compact. The tangent bundle is maximal isotropic. Therefore, locally, the form can be used as locally at a smooth point. So when I say tangent bundle, I mean smooth point. Smooth point. I'm giving this definition because they will appear Lagrangian fibrations in real case. Will appear, I think, in some other lectures here on SYZ problem. And so locally we have coordinates T1, Tn, and let's say T1, Tn, T1, Tn, at smooth points, again at smooth point. Smooth point OP, such that the form W locally in a small neighborhood like that is just dt, some dti, dt. So that's a case of general kind of Lagrangian fibration on complex variety. It's essentially responds to what is called completely integrable Hamiltonian system. In our case, in the case I'm considering, we have x to n, x to n. Here is a complex Kahler manifold. Kahler manifold. Compact. And projection. And this is complex projection. V is VW0. So complex holomorphic form. Please ask questions if something is not clear.
Yeah. Can you write larger letters?
Larger letters,
Could you at least use a black
Yes, okay.
marker?
Yeah, okay. Complex holomorphic form, non-degenerate. Okay. Holomorphic form. And respectively t to the power n. Here n is the number of complex parameters here. So here is 2n and the holomorphic form, and Tn are complex. Okay, so in that case, so the notion of hyperkahler is related to the fact that if you have a Kahler variety, I'm going to discuss a case simple hyperkahler. Simple hyperkahler. So this is a particular case to me of a hyperkahler manifold. And simple hyperkahler means simply that there is a unique modular constant for simple hyperkahler. I won't get deeper into this hyperkahler. Means x to n. In principle, there may be no Lagrangian fibration. So Lagrangian fibration is a particular property of some hyperkahler manifold. And x to the power n is simple hyperkahler is h to 0. So of x to the power n omega 2 is dimension. So this is a small h means dimension is equal to 1. And so that means, and v, so v here, so that means the holomorphic form is uniquely defined modular constant, modular multiplication by constant. And moreover, okay, I'll say phi 1, h1. So it's simply connected, and there is a unique w to 0 holomorphic form. And plus it is scalar, plus scalar. On some of these varieties, there are Lagrangian fibrations. And the point of talking about Lagrangian fibration is that these are the only hyperkahler variety in high dimensions, for example, which basically can be handled. So first, this theory started with example. And with example are K3 surfaces. K3 surfaces appear as surfaces, so as they appear as surfaces S or in degree increase. So that means smooth surface of degree 4. That means P3 means 4 homogeneous variables. And if you consider the sum xi4 equal to 0 from I equal to 1 to 4, that's a simple example of a very symmetric K3 surface. So in that case, we just can compute. So if you have a hypersurface, it defines a bundle, and the normal bundle is basically the same bundle as restriction of the same bundle. So just by simple topological computation, we have C1 of S4 equal to 0, and in fact, what is C1? This is so-called essentially C1 minus C1 beta of the canonical class, which is omega 2 in this case. So K3 is a surface. It's simply omega 2. That means the bundle of local sections of type dz1, dz2. So local sections are volume forms. And in particular, not only C1, but just canonical class equal to 0. And the section of this canonical class class is trivial, therefore section is nowhere zero.